We will go back to that, that equation thing, which in which there is the antimatter things as well. I've actually missed that somewhere, but I will find it out. You know, what is nuclear binding energy? So, but nuclear binding energy is the energy that actually controls, or that actually, you can say, take care of the neutrons and the protons together. So basically, experiment into nuclear structure have found that total mass of the nucleus is less than the sum of the mass of its constituent nucleons. The point is, why is like that? I mean, if the total nucleus is based on the total sum of the nuclear neutron and the proton, why the mass is less? What do you think of it? Yes, Manu. What do you think? Why is the case? The total mass of a nucleus must be the mass of a proton plus the mass of a neutron. But actually, the mass of a mass of the nucleus is less than the total mass of a proton plus the total mass of neutron. So where is the difference gone? What do you think of it? That mass difference is
In
called as mass
energy?
defect. This is what we call as mass defect or mass deficit. Or mass deficit is defined as a difference between a major amount of a nucleus and the sum of the total of the masses of its constituent. Okay, this is one very small topic related to our course. So, if I ask you what is the mass defect, so mass defect is equal to ZMP is equal to A minus ZMN minus the total. Now, what exactly it is? Z means the proton number, and MP means the mass of a proton. So basically, total mass of the proton plus A minus Z is how much? A is the mass number minus the atomic. So basically, this is the total number of neutrons multiplied by the mass of a neutron. So sum of number of protons plus sum of number of neutrons minus the mass total. Now, what is mass total? Mass measured of the nucleus. So that difference is called as mass deficit. And please remind me next time that we have that equation of, that anti-mass thing in which positron is actually originated, and the other one I've missed somewhere, but I will find it. Do you understand this equation, or still there is a problem? This Z means proton number. MP is the mass of a proton. So total mass of a proton. A minus Z is the total number of neutrons. So each neutron mass is Mn. Multiply by that and you will get total mass of proton plus neutrons. And this is the mass of a nucleus. Now, once we understand with the nuclear binding energy, now, due to mass energy equivalency, this decrease in the mass implies that energy is released. So, very simple means is definitely the energy releases. Now, if the energy releases, what energy is releasing? E is equal to mc square. It means that some of the energy releases while there is a force of attraction, or you can say a binding energy needed for that. So energy and mass are proportional so that the total energy of the nucleus is less than the sum of the energy of its constituent. So binding energy is defined as the energy required to break a nucleus into its constituent proton and neutron. So basically, what important point at this point is that mass deficit tells us that some of the energy is released. Now, what is that energy then? That energy must be the energy that actually breaks the nucleus into its constituent protons and neutrons, and that energy can be given by E is equal to mc square. That is again Einstein theory. Okay, so Einstein is given that theory. So formation of a nucleus from a system of isolated protons and neutrons therefore release energy, and making is an exothermic reaction. So it means when energy is released, it is an exothermic reaction. So what is binding energy? Energy required to break a nucleus into its constituent protons and neutrons. Quickly write that as well, please. Do not need to write everything, but write some important points like binding energy and some main concepts so that you can afterwards go through the lecture as well.
Yes, sir, I'm done.
Done? Now, another very important thing. Why this energy, why the formula is E is equal to mc square? Now remember that according to this formula, it means that mass can be converted into energy and energy can be converted to mass. Like if a mass is moving with the speed of light, that is c, c means the speed of light, then it means that it can be converted into energy. Let's suppose if I have my weight 90 kg and I am moving with the speed of light, then this particular formula will give me how much energy I will be actually liberated it into, or I will be actually converted it into. So this formula gives us that what is that energy conversion if a body is moving with the speed of light? E is equal to mc square. Now, very interesting fact. The fusion reaction and the fission reaction. The question is, how do we calculate the energies? Now, important thing is during the fusion reaction and fission reaction, how do we find out that how much energy is liberated or actually consumed or whatever? The way is very simple. We actually form, I mean, we do left hand side and right hand side comparison and we see how much energy we given and how much energy we have produced at the output side. You know, especially when we do fission reaction, what we have done that input side or reactant side and product side, during the reaction, the input should be equal to the output. But the point is, what we have found out that output is more than the input side. So what amount of energy is released? This is the amount of energy which is released. So technically, once we use this equation E is equal to mc square, we found out that the amount of energy is actually equivalent to E is equal to mc square. It means that some of the mass of the reactants are used to convert it into the energy form and the rest will be converted into the product form. So basically, this E is equal to mc square is very much used in, these fission and fusion reactions as well. So initially it was started with the theory, but when during the calculation we use that equation E is equal to mc square, we found out that as per our calculation, the amount of energy which is released will be equal to E is equal to mc square. How? Now again, as we have done few minutes ago, that there is a nucleus, there are let's suppose two protons and two neutrons in certain elements. Okay. The point is, my question to you is theoretically, if you ask me, mass of mass of nucleus and mass of two proton and two neutron should be equal. Am I right?
Yes.
But practically, when you do that, there is a deficit. It means that sum of the mass of proton and neutron, when you add them, it will not be equal to the mass of neutron. It means that some of the total proton and neutron mass, some of the mass is actually converted into energy. Same thing happened in the reaction as well. And that amount of energy can be given by E is equal to mc square. And when the amount of energy released, and when we found out the amount of energy by using that deficit mass, by using mc square, we found out the amount of energy released, and E is equal to mc square, energy will be same. It means that it verifies that E is equal to mc square is actually applied over here. Okay, so E is equal to mc square has so much applications. As we move to the other part of that photoelectric effect and everything, you will find over there as well. Now let's see the question here. They say the binding energy per nucleus is 7.98 mega electron volt. If you remember, I have told you how to convert it into mega electron volt. How to convert mega electron volt into simple joules? If you remember, Manu.
It's supposed to be times 6 times 10 to the power of negative 13.
Not negative 13. 1 electron volt is equal to 9.1, no, 1. What is the charge on an electron? I forgot actually. It's 1.6 or 1.9, I think. I think so. We will see to it. If I have what is the charge on
1.6
electron?
times 10 to the power of negative 19.
Yes, it is. But in that case, it should be mega. So 10 raised to power 6 multiplied by the
1.6.
yeah. So basically, in that case, if we want to convert it into joules, then it will be 7.98 into 10 raised to power 6 first, and then electron volt will be 1.6 into 10 raised to power minus 19. And that energy will be converted into joules. But here, let's see what they are asking. They say binding energy per nucleon is 7.98 mega electron volt for an atom of oxygen 16. Determine an approximate value for the energy required in mega electron volt to completely separate the nucleons of this atom. How will you do this? Energy is given per unit nucleon. Yes, Manur, can you hear me again? So what to do in this? How will you proceed? Now the binding energy which is given to you is 7.98 mega electron volt, and that is binding energy per nucleon. How many nucleons you have altogether? Altogether you have 16
16.
nucleons. So multiply it. That's it. That's all. So you will get the energy 12.7 mega electron volts. That's it. That will be the total binding energy. So if binding energy per nucleon is given, you can simply multiply it and you will get the binding energy of the total. So this is sorted. I mean, done. Now, atomic mass unit. This is something related to, you can say, it's all related to the, what exactly it is. This is related to the uh, chemistry, actually. So what is atomic mass unit? It's a mass of a unit. I mean, 1 unit mass of an element, something like that. So you can say that, like, for example, you have 1 proton, 1 neutron. Electron mass is all means it's totally negligible. So basically, a unified atomic mass unit is roughly equal to the mass of 1 proton or neutron. The question is why it's 1 neutron or 1 neutron or a proton or neutron. Why not electron? The reason is very simple, because electron has a negligible mass or very small mass as compared to the proton and neutron. So and the unit we called it AMU, atomic mass unit, is commonly used in nuclear physics to express the mass of subatomic particles. It is defined as a mass of exactly 1/12 of an atom of a carbon 12. So basically, when you define it, you say that you're comparing it with the carbon 12. You say that mass of 1/12 of an atom of a carbon 12. So basically, one atom of carbon 12 has a mass of exactly 12U. Now 12U means, since 1U is equivalent to 900 and okay. Now important thing is, this U means a value. So 12U means what? U is a simple unit. 1 unit is equal to 1.66 into 10 raised to the power minus 27. So 12U will be equal to 12 multiplied by 1.6 into 10 raised to the power minus 27 kilogram. So if I ask you what is the total mass in kg, then you will multiply the atomic number, or no, mass number, which is number of protons and number of neutrons, with this particular unit 1.66 into 10 to the power minus 27, it will be converted into kilograms. But if I ask you simple question, what is the answer in AMU, you will just place U along with the proton number. I mean, not proton number, with a nucleon number. In case of carbon 12, the mass number or the mass of exactly carbon 12 is 12U. Now, important fact is mass and energy are interchangeable. So AMU can also be expressed in mega electron volt. 1U is equal to 931.5 mega electron volt. So now two things we have studied here, that unified atomic mass unit, which is represented as small u. And this is equal to mass of one proton or neutron, which is equal to 1.66 into 10 raised to the power minus 27. Now, how to convert? It means 1 U is equal to this much. So now, for example, if the nucleon number is given to you, how to convert it into kilogram? You simply multiply the number of protons plus number of neutrons with 1.66 into 10 to the power minus 27. So you will be converted into kilograms. Second thing, 1 U value can also be expressed in terms of mega electron volts. So again, if I ask you what is the total mega electron volt released or whatever you want to say, then it will be 12 into 931.5 mega electron volts. So you will get your energy released for 12 U as well. Manur, any question in this?
No, sir.
Okay. Now let's see the table here. Particle is proton. Atomic mass unit is 1. AMU. Neutron is 1. Electron is 0.0005, which is very less. Now check this one out. Why this is 4? Because there are 2 protons and 2 neutrons in this. Now, some example is being done here for you. For example, the mass of uranium is 235. So roughly in AMU, the value will be 235 U. So notice that the actual mass is slightly lower than the expected mass due to mass energy equivalency. So AMU might be quoted in kg or mega electron volts, its mass energy are equivalent. Delta E is equal to mc square. I want you to just write these conversions, which will help you in solving the numericals. Only conversions and definition for the atomic mass unit. Quickly, please. Okay, Manur, did you copy?
Yes, sir.
Okay, got it. Now, I think let's do the numericals. Let's say estimate the mass of nucleus of an element copernicium 285 in kilograms, giving your answer to 2 decimal places. Now you need to remember that value which is given upstairs. What is that value? 1.66 into 10 raised to the power minus 27 kilograms.
So the 285 is just the protons, right?
Yeah, 285 is not just proton. It's proton plus neutron. It's a nucleon number. This particular 10 raised to the power something value is you need to memorize it. It's not difficult to memorize. 1.66 into 10 to the power minus 27. It will not be given to you. Might be it will give you, they will give you a separate page for that or not, but you need to memorize that. Some values you have to memorize. I believe they normally used to give it. What do you say, Manu? Will they provided you the values of the constant? I think so. They do that.
Yeah.
But I think you better memorize it because don't trust on them. Might be they do that or might be not. There are few values you have to memorize. If you keep doing practice, I tell you, you will memorize it. 1.66 into 10 to the power minus 27. So what is the value?
It's 4.7.
Into 10 to the power?
It's 10 to the power negative 25.
Very good. Let's see. Yes, it is. If I ask you to convert it into mega electron volt, then it's there. Conversion is this. Let's see that. Yes, 1 U is equal to 931.5 mega electron volts. 931.5. So how much is it? 285 multiplied by 931.5, which will be how much?
It's 2.7 times 10 to the power 5.
Right. And that will be mega electron volt. If you want to convert electron volt, I mean, that will be 1.5. For example, the question is that you need to give answers in joules. Then mega means 10 to the power 6 and 1.6 into 10 to the power minus 19. That value will be given in the form of joules. Right? Shall we move
Yeah.
on? Manu, any questions till now?
No, sir.
Thank you. Okay, let's move on now. Let's test yourself quickly. A proton has a mass of 1.67 into 10 raised to power minus 27 kg. Which of the following shows the conversion of this mass to GeV upon C square? What is this GeVC upon C square? Okay. This is E is equal to MC square technically. Conversion of mass to G. This is the formula actually. Let me just see. E is equal to MC square. So what they're saying is which of the following shows the conversion of mass to this? Now mass is how much? 1.67 into 10 raised to power minus 27 multiplied by C. So which one is it? Which one it looks? That one is not possible because C is in the denominator. That one is not possible because C is in the denominator. The only one is this, which is C, in which C is in the numerator. So definitely this is the one. So let's see. So correct answer is C. Oh, no, it's C, sorry. So how did they convert it? Actually, they convert 1 electron volt into 1.60 into 10 to the power minus 19 joules. Then 1 GeV is equal to, now this is another thing actually. I didn't notice that. 1.6 into 10 to the power minus 19 multiplied by 10 to the power 9. It will be converted into 1.6 into 10 to the power this. I don't think so. This one is a part of our thing. Let's move further. Okay. Let's do it. Let's move on. I don't think so. This is the one which actually I should have mixed up. Okay. Now binding energy per nucleon graph. We have done few minutes ago this one. When I say binding energy per nucleon, you divide the total binding energy with the nucleons or with the nucleus, and it gives you basically binding energy of the nucleus divided by the number of nucleons in the nucleus. So basically, binding energy per nucleon graph. This is the one we have it. Now, interesting fact about this graph. The graph comes like this. Okay. So what does it tells you? Key features of the graph. At low value of A, nuclei tends to have a lower binding energy per nucleon. Hence, they are generally less stable. This means that lightest element have weaker electrostatic force and are the most likely to undergo fusion. Now, this is very interesting part. Can you tell me why this is the case? The statement they say, read it again, they say nuclei tends to have a lower binding energy per nucleon. Hence, they are generally less stable. This means that lighter elements have weaker electrostatic force and are mostly likely to undergo fusion reaction. Why is like that? Why the element having, lesser, what you call it, number of nucleons have a lower binding energy per nucleon? Yes, Manu, what do you
They
say
have
now?
lower energy.
Very simple case, because in the nucleus, you will have number of protons plus the number of neutrons in lesser quantity. So they have less binding energy, or you can say they have less electrostatic force. So to fuse them together is easy for us. So that is the reason actually the element having less, mass number, or you can say atomic number, they are generally undergo fusion reaction rather than a fission reaction. But as you proceed towards the bigger atomic number, then definitely it will go into the fission reaction because the number of protons will, I mean, number of protons and neutrons will increase. It means the electrostatic force between them increases. So if you see the graph here, initially the binding energy will be less. You have to actually provide less energy to break them. But as you proceeded, it will increase and increase and increase. And when you reach to this point, it will again reduce because there are spontaneous fission reaction already occur in this. So here you have to do induced fission reaction. But at this point, when it comes to uranium, they have their own fission reaction occurring. So they are not stable in nature. So that is the reason you can see the binding energy per unit nucleon reduces from here as well. Initially, it's increasing, but it's less. But here at this point, it's increasing again. And then as soon as we go into the region where the number of protons and neutrons increases, they become unstable and unstable and unstable. And once they become unstable, it will go towards the fission reaction. Manur, any question in this?
No, sir.
Very simple. I want you to write this in your own words, or at least write this one, but do not write each and everything in this. Okay. Don't need to write everything, just write some key points and also draw that rough graph and write the explanation. And first write this one, and then I want you to write the next thing. So highest binding energy means the most stable element, which is barium. I mean, barium means iron. You know what does it tells you? It means that before iron and after iron, you will have energy per unit nucleon. First one, it's increasing. The second one, it's reducing. So barium or iron will be the middle one, somewhere here. So this is the boundary till iron. The tendency of the element is to have to go with the fusion reaction. And then after iron, the tendency of the element will not be going towards the fusion reaction, but towards the fission reaction. I want you to write this explanation as well. Wait a minute. Write this explanation as well. Manur, any question in this explanation of the graph? Manur, your this paper, I mean, this mechanical paper is on 7th. And then when is the waves paper? That's the unit 3 paper?
It's on the 20th, I think.
And you're not taking the third one. Okay, can you find me the binding energy per nucleon for 56 barium 26 in mega electron volts? First find the total energy and then divide it by 56. We have already noted, what is that energy? I forgot the value. What is that value? If you just memorize it, or no, if you don't memorize it,
931.5.
Yeah, so 931.5 into 56 will be the total energy, I think. And yeah, mass of neutron. Okay, they actually found out the total masses. So mass of nucleus is 90. Oh, right. Okay. Determine the binding energy. Now, what they did is they find out the energy of the neutrons, then energy of protons, and mass of the nucleus, which is by actually, how did they find out? Mass of okay. You know, how did they do this? I believe. Wait a minute. Let me just check it out. Right. I think so. In the question, they are given this one. Yeah, that is given. Now, when this kind of question comes, this is interesting if the values are given. So you have to apply the formula. First thing first, let's find out the mass of a neutron. First of all, can you calculate what is the total number of protons and number of neutrons? Manur, can you find me
Protons are
the
26.
protons are 26 and the neutrons are 30.
30.
Okay. Now, once you found out Now, mm, mass of each neutron is 1.675 into 10 to the power 20 negative 27. So what is the total mass now? If I say total mass of neutron, we have done a formula very at the first place. That formula I am applying, but I am doing in a break so that you will be understanding that. So number of total mass of neutron will be 30 multiplied by 1.675 into 10 raised to the power minus 27 kg. So what is the value coming up? Total mass of neutron? Yes. What
I
is it?
have 4.8 times 10 to the power of negative 26.
4.85 into 10 raised to the power minus negative 26.
Yeah.
This is the total mass, right? Now let's find out the proton total mass, which is 26 into 10 1, I mean 1.673 into 10 to the power minus 27. Now what is it? Total proton mass.
It's 4.1 times 10 to the power of negative 26.
4.1 into 10 to the power.
Negative 26.
Okay. Now, can you find the total mass of proton and neutron by adding them? So what is it?
It's 8.95 times 10 to the power of negative 26.
Now, I can see that this mass is greater, technically speaking, and this mass is greater, the mass of the neutron, and this mass is lesser. Which mass is greater, by the way? What do you think?
Neutrons.
The sum is greater or the mass of a nucleus is greater? It looks nucleus is greater, right? So now you subtract it. 9.288 into 10 raised to the power minus 26. This is what we found out, mass deficit, minus 8.95 into 10 raised to the power minus 26. So how much is the mass deficit?
0.33.
0.33 into 10 raised to the power, 0.33. Now this is your mass deficit, right? Now you need to convert it into mega electron volts, right? So how to do this? Very simple. 0.3. The formula is E is equal to mc square, where mass is the one which you just found out. So 0.33 into, now this one is 3 into 10 raised to the power 8 square. So what is it?
2.97 times 10 to the power of 16.
2.97 into 10 raised to the power 16. Okay. Now this one, what is the unit for this? Joules. It's not yet in mega electron volt. Now check this out. 7 point. But why this is 7 point this? So you give me a wrong value, check. When you subtract it, it gives me 8.680 into 10 to the power minus 28. Where is the problem coming through? 26 into 1. Okay. What's the problem? The sum is equal to whatever. What is the difference in here? The value of the difference is coming as this one. I think we have missed something. You have to recalculate that value. The value is coming as at basically 8.680 into 10 raised to the power minus 28 kilograms. That is the mass deficit. Now use this one, 8.680 into 10 raised to the power minus 28 into 3 into 10 raised to the power 8 square. When you do that, you got a value equals to 7.812 into 10 raised to the power minus 11 joules. Now, Manu, how to convert joules into mega electron volt? The first thing you will do it to convert this into electron volt. Now, how to convert it into electron volt? First of all, this is the total energy, right? So how to convert it? You divide it by the total number, which is equal to 7.812 into 10 raised to the power minus 11 divided by 56, which is equal to 1.395 into 10 raised to the power minus 12 joules. This is basically binding energy per nucleon. Now, can you tell me, Manu, how to convert joules into electron volts? When you convert electron volt into joules, you multiply it. When you convert joules into electron volt, you divide it. So 1.395 into 10 raised to the power minus 12 divided by 1.6 into 10 raised to the power 19. Can you tell me the value, please? Now this is in electron volt, but they ask us in mega electron volt. So for mega, you have to divide it by 10 raised to power 6. So when you do that, it will be 8.3 mega electron volt. Check it out. Approximately 8.7 actually. Small calculation thing. So basically, there are few steps involved in that. First step is to find out the mass deficit, then convert it into E is equal to mc square, binding energy. And once you find the binding energy, that will be the total binding energy. You divide it by the nucleon numbers. And then once you do that, you have to divide it by electron charge. And then you convert it into 10 to the power 6, and you divide it by 10 to the power 6 to convert it into mega electron. Yes, Manur, any problem in this, beta?
No, sir.
So I think we will stop our class here. Inshallah, in the next class, we will continue with that. And of course, we have equation of mass and anti-mass, which left behind. All right? Did you copy this?
Yeah. Yes, sir.
Okay, then. See you in the next class. Then. Take care. Bye.